Okay, welcome to the first kind of thing we have to figure out here. I've got everything stripped down right to its barest parts, and now we have to do some math to figure a few things out. I need to know how fast it's going to go. I want to limit the speed of this thing to probably 25 kilometers an hour. I don't want it to go too fast. I want it to be, kind of controllable, and if something goes wrong, I want somehow to be able to stop it easily and safely. It's going to weigh a couple hundred pounds, so, if it hits somebody or hits something, it can do some serious damage. So we're going to try building some safety and some controllability into it right in the beginning. So one of the first things you need to know is how fast it's going to go, or on paper, how fast should it go? Things I know and things I don't know. I don't know how much force it's going to take to move it forward. I don't know how much current it's going to take to drive it. I'm not sure I can do the math on the force going forward, but I think I'm going to do it more experimentally than that. Instead of doing all that math, I'm still stuck with what I have here. So there's no point or for me anyway, there's no point in finding out what it should do because it's going to do what it does. But one thing I have control over here, one thing I can do is control how fast the rear axle spins. And if I know how big the wheels are at the back, then I can use those numbers to figure out how far it's going to go at certain RPMs, how fast it's going to go, how many kilometers per hour it will go mathematically. So I know a couple of things. I know I have a motor that spins at 72 RPM per volt. And I know I have 48 volts worth of battery, so I can figure out how fast this motor should spin mathematically in a perfect situation. I know how many teeth I have on the sprocket here. I know how many teeth I have on the sprocket here, and I have an assortment of sprockets that I could to choose from.